Good day once again, class. This is Mr. Simon. We are going to go through the ethanol industry. I want to once again highlight key points. The goal is not to be long, but just to focus on critical things that you need to be aware of. One important thing about the ethanol industry is that it has a social aspect in a way that the other industries do not exaggerate. Just some brief recap of ethanol. You know that it's a volatile, flammable liquid and so on. It can be used as a fuel as well as a solvent. The molecular formula you know, but it's important to know that it's an OH group that helps to give the ethanol a lot of its characteristics, like polarity and so on. How is it made? So fermentation is one main process. The other one is the hydration of ethane. Well, that's really straightforward. With fermentation though, you would use yeast or bacteria, and what happens is the yeast is actually able to use an enzyme we ultimately call zymase that can produce ethanol, or it can use invertase to break down something like sucrose into glucose and fructose. Let me get my pointer out. Yes, so it can break down sucrose into fructose and glucose. Alright, so the thing with glucose in the fermentation process is that ideally you want to have it between 50 and 40 degrees Celsius, and that's because you don't want it to be too cool or you don't want it to be too warm. If it's too cold, then the enzymes won't work properly. If it's too high, then it would actually denature the enzymes, remembering that enzymes are proteins. Alright, also you want to be careful of oxidation to ethanoic acid and the unwanted side reaction if it's left exposed to air. Alright, so the process generally takes about 3 days, but the yeast cannot tolerate a concentration greater than about 15%. That's why you can't use fermentation to get alcoholic beverages greater in alcohol content than 15%. So things like Cavalier rum and so on, that are about 40%, they would not be able to use solely fermentation. Alright, now fraction distillation is a technique that you can use to get even more, a greater concentration of ethanol. However, you are aware that an azeotrope is formed. That azeotrope, it contains about 95% ethanol and 5% water, and notice that it boils at a lower temperature than ethanol. It's called a minimum boiling point azeotrope. So it's called a minimum boiling point azeotrope, and because of that phenomena, it's not able to 100% separate. Azeotrope actually means, the word means cannot be distilled. So if you wanted to get 100%, you would have to use additional techniques. Perhaps you can use a desiccant, something like silica, to help to extract out the remaining water. Alright, this is your setup. Okay, now since I hear you have the alcohol and water mixed together, this is your fractionating column. These layers here actually provide a surface in which the evaporation condensation can take place. Alright, and we didn't actually use that, we just left it open. But if you add beads or add some sort of substance, the surface provides that opportunity and you have more efficient separation. Okay, that's why when you get over to this curve, let's say you started off with 50% ethanol, which will be about here. Okay, once you go up this curve, you see that mixture, whatever beverage that was, it boils a little lower than 100%. You come over here, come back down, you see the composition of the vapor as well as the liquid. So you see that the first time your vapor condenses, let's say it condenses here, okay, it's going to be a little richer in alcohol than the original mixture, and then that vapor is going to evaporate and condense. Let's say it condenses here again, then that new liquid that condensed would have a composition of about this. So you see that every time it goes up again and condense. Every time it goes up and condenses, you come a little bit more across the graph, and you keep doing that. So you have evaporation, condensation, until you get to this azeotrope here. then you're stuck there. That part, at that point, you don't have a component that's more volatile. The most volatile component is the mixture itself, so it cannot be distilled past that. But these, you call them plates. These stages right here, we call them plates. The more plates you have, the better. Okay. But these are really evaporation condensation cycles, and it's important to note that if you have beads in a column, it actually helps to enhance this. Okay, some uses as a fuel, solvent, cosmetics, perfumes, antiseptic, food, alcoholic beverages. We do use alcohol in cooking, alcoholic beverages in cooking. There's some visual examples. Alright, now this part I really wanted you to look at. There's something called blood alcohol concentration. Okay, here it's abbreviated as BAC. But the blood alcohol concentration basically shows you the concentration that can be in a person's body and the short-term effect that it will have. Alright, so for example, at a BAC of 0.5 grams per dm cube, you have things like increased talkativeness, and you've probably seen that in someone somewhere. Persons feel relaxed and so on. At a BAC of 1.0, you have giddiness, vomiting, intoxication, slurred speech, aggressive behavior. Then at a BAC 3.0, grams per dm cube, it becomes a bit dangerous. You can lose consciousness, you don't know what's going on, and anything above 4 grams per dm cube can result in death. Right down here you see a breathalyzer test. Okay, this one looks a bit digital, but the initial ones used to be just vapor. Now there are some videos of some students. They actually, excuse me.
We have increased confidence.
Okay, so these students, a few years ago they put together these videos to show the effects at those particular the different BAC concentrations, and you see at that one they had that response. It kind of just not really mocking, but demonstrating how persons respond at different BAC, and this one was just talkativeness.
We have increased confidence.
Then we move over to BAC 1.0.
Look this yummy mango.
Okay, that wasn't a mango, it was a stone. That was a mango. Okay, so that's the guy, gentleman at 1.0 grams per dm. Then finally at BAC 3.0, you have that. Some of you may have recognized those young men. Alright, then long-term effects, you should be aware of these also. You have cirrhosis of the liver, gastrointestinal problems, addiction, which seems to be a major problem here in the Caribbean. You can even have death, you lose brain cells, you lose your memory. Birth defects can be facial abnormalities, and children developing in less than average intelligence. So the alcohol is not just affecting the individual, but it's affecting the young ones that are coming up. And that's how cirrhosis, a liver that's suffering from cirrhosis looks. And this is an example of a deformity. I think it's called cleft. Alright, now the social impact. Now remember we said that the alcohol topic has a social aspect to it. One is that, drivers are impaired because of alcohol. If they're intoxicated, then it can result in the loss of their life as well as the loss of their passengers or other pedestrians, other road users. And we've seen that happen in Antigua quite a bit. And that's interesting. It's when I say interesting, I don't mean it's a good thing. I just mean that it's something that's different than the other industries, because the other industries tend to just stay in location. But here you have alcohol spreading, and it's affecting, it's those who are affected by it can affect others. Long-term isolation, persons who they tend to isolate themselves from other people if it gets very severe. Sometimes we see vagrants on the streets, like when you walk into the learning center, that area. I'm not making fun, I'm just saying that's a reality. And one of the effects or impacts is alcohol caused that. Alcohol helped to cause that. Alright, you have an increased number of liver transplants because person's liver got damaged. Then you have people being a little bit more unproductive or less productive because of hangovers and other things like that. Absenteeism can also increase. And that's it.